Hello everyone, I'm Rafael Cota, I'm the captain of the Antares and from UNICAMP, and we are very happy to be here to present our mission. So about the mission, the name of the mission is Anhangá, and more about the history. It started in 2018 because this is the first rocket that the team fully developed, so all the parts and components were designed by the members, and this is a 500-meter apogee rocket. And now let's get into the presentation about the subsystems and all the components and all the parts of the work.
Hello everyone, my name is Rafael. I'm the leader of the Structures and Aerodynamics department at Antares. I'm here to talk about the subsystem. We decided on going for a von Karman nose cone, a fuselage made of fiberglass only, trapezoidal fiberglass fins, we used 4 of them, and here are the dimensions of the rocket. An interesting thing to point is that we decided on splitting the rocket in 2 pods, 2 fuselages, in order to make it easier to assemble everything up, and we used the coupler to unite the parts. Here is a closed loop at our nose cone, a drawing a crew, and it's the white nose cone shown in the picture. In order to laminate the fuselage, we used this PVC base with a broomstick as an axis, and we laminated using epoxy resin and hardwood. The fins are made of fiberglass as well, and here are the dimensions of it. We laminated squares of fiberglass and we cut it in the right geometry. Here are some of the tools used, and we can see a close look at the open rocket model. We had reached the stability of 1.79, stability caliber of 1.79. And here's the final state of the project. It is very satisfying to look at it. Some additional thoughts about the project is that we used an octagonal shaped parachute and efficient swivel in the parachute so the shroud lines don't mess up during recovery. And here's some of the flight simulation data: the velocity of trail, apogee, max velocity, max acceleration, and ground heat velocity.
Hello everyone, my name is Mauricio and I'm the Propulsion Division Leader of Antares. Today we're going to be talking about the propulsion system of Anhangá, starting with the engine. This is a Scorpio. It is our first engine and it uses solid propellants and was projected to reach half a kilometer. The solid propellant it uses is a KNSB mixture with Beta's geometry. It is 65% KNO3 and 35% sorbitol. And this is the ignition system. It uses a mixture of charcoal and KNO3.
Hello everyone, my name is Gabriel and I was explaining the avionics on the Anhangá rocket. The goal of the avionics is to trigger the recovery system and also to store the flight data of the rocket. This flight data is acquisitioned using 2 redundant BMP280 barometer sensors. This data is then processed using an Arduino Pro Mini, which is a commercial off-the-shelf component and therefore non-expensive and also fairly easy to develop using available libraries on the internet. We then store the data on the SD card for getting the flight data and recovering it after the flight, and also this data is useful for activating the igniter, which is our interface with the recovery system. In the end, we also have a buzzer that will be activated once we are back on the ground for making it easy to know where the rocket is and to recover it.
Hello everyone, Rafael here again to talk about the recovery subsystem. So we opted for an octagonal shaped parachute with the biggest diagonal of the octagon to be 1000 millimeters long. We used 8 nylon shroud lines and aluminum plate to protect the parachute from the heat from the ejection charge at the nose cone. It has a packed length of 150 millimeters, a efficient swivel in the parachute so the shroud lines don't get messed up during recovery, and we used a screw axis held by nuts in order to lock the parachute in.
When it comes to the ejection of the nose, we use crimson powder, which is 55% KNO3, 40% ascorbic acid, and 5% iron oxide. And because it burns through our parachute, we had to put protection bullets, so we don't have to worry about it.
So thanks for your attention. Again, we are very happy to present this project and we hope the best for all the teams in this competition. Thank you.